Hi, everyone, and welcome to another Hackaday session. This Hackaday session is going to be a continuation of what we did last month when we looked at integrating Spark for analytical purpose with some NoSQL database. So if you remember from the last month, we looked at integrating Spark with MongoDB. Before we started, we set a tune for the case of using NoSQL databases even as big data engineers. And we looked in depth into MongoDB. In this Hackaday session, we are going to use the same data sets and the same use case for storing our data with Cassandra. And we're going to look at possibilities for reading and writing data as well as performing analytics. So we're going to look at it from both ends. So for it to make sense and to set the stage, even for those who who have not seen the last month's Hackaday, it'll make sense for me to just take a few minutes to go back to what we did in the last Hackaday session and set straight that objective and say, hey, this is the same kind of objective we want to do with Cassandra. Then after then, we will move on to introduce Cassandra and look at the use cases. Is it a great fit for this use case or is it not? I would really want you to decide, but however, while having this Hackaday, you're gonna see the hints. Then once we have made a decision about what is Cassandra, I will try to go in depth into how Cassandra reads data, how it writes data to set the tone for you to understand where to use data or where to use Cassandra for data analytics or data analysis. Also, we are going to install our first Cassandra installation in our local machine, and we're going to connect it with our Hortonworks sandbox that we are using and which we used for the last session. So once you've installed it, we're going to create a sample key space, a sample table, and you see how to read and write data using the Cassandra CLI. Then we're now going to pivot to our main data set and explain all we're trying to do in the context of using Cassandra for our use case. So exploratory look at Cassandra, we're going to talk a lot about data modeling, and in data modeling we're going to make mention of things like materialized views. Then we'll come to the big ball there, that is Spark integration using our data set. Then we'll look at, as we speak about this, you see the use case of Cassandra in the enterprise, and you ask yourself, should we use it for OLTP systems or should we be using it for big data analytics system? Then once we have done all these, especially integrating Cassandra with Spark using the data stack Spark Cassandra connector, we are going to now compare. So the last thing we're going to do in this Hackaday is compare. I want you to convince yourself about the comfort of doing analytical query in MongoDB and Cassandra, so that you can close your eyes if you go for an interview, if you have a time to talk on technology, you can make a very informed decision. And if you're already using Cassandra or MongoDB, or you work for an organization that is planning to do any of these, you can make more informed decision. By the way, it will be appropriate to know that all the code that we're using for the class, even the one we used for the last session, they are in my GitHub repository. So you can go to Spark exercises from my GitHub repository and Spark MongoDB Cassandra. So all the DDLs and the projects, they're available there. So at this stage, let me just take a review of what we did last week, and let's see some exercises. So if we go to the Hackaday introduction page, you would see that we are trying to take data set that's already available online, and we're trying to load it into one of these NoSQL databases. Obviously, it is simple to load it into HDFS because we did that. However, in the data set, we have a documentation that comes with it. By the way, the document is about the Ministry of Transportation vehicle testing data sets. They have a lot of large data sets there, and we use the smallest of them all for this exercise. So this is the documentation that comes with the data set, right? And you can read down the purpose of the data set, but I'd rather jump down to the description of the data set by showing the entity relational diagram. So to bring the business context, this is about vehicle testing. So when you take a vehicle and to the Ministry of Transport's accredited centers for testing, the vehicle is going to go through testing. Now, two results could come out of testing. It's either you pass, you can see the results here. You can either do a normal MOT testing, a statutory appeal, a partial retest, and you can see that. When you do testing, it's either you pass or you fail, or you pass with rectification, abandon, abort, and you can see the purpose. Now, let's just say you pass or fail. Now, if you pass, you get a test result that shows you pass, and that's all. However, if the test results for the vehicle fails, then the tester has to say the things that failed. Now, on this entity relational diagram, the items that fail are called test items. So if everything passes, passes, but if it fails, you have a test item. And a test item will be one or more items that failed testing in the test result for the vehicle, right? And you have things like the failure location in the vehicle and details of the test items, and test item details are also will also belong to one or more groups. They have groups as their parent, and groups are hierarchical in nature. So a group can be a child of another group, and as we'll see in the data set. So from this documentation, like I said, quite a large data. Good. So quite a large data. You will see the link on the GitHub site, the link to get these data sets. The resource link is here, so you don't worry if you don't have it. And you have a lot of data. Like I said, one data alone, the smallest data here contains about 7 million records, and that is the data for 2005. And because we're doing this in a single node HDP cluster, I figured we should use the smallest so that we pass the message across, and you still, then if you have a big cluster or you have a bigger machine where you want to practice these, I suggest you use more than 1 year. Probably use up to 50 million or even 100 million records. Then these explanations that we're trying to make about NoSQL systems, HDFS, Spark integration, it's really going to be a fruit. Even though in this hackaday, you're literally going to see the fruits. But as you increase the size of the data, the difference in performance becomes more and more conspicuous and more noticeable. So we have the data, and let's take a look at what we did last month. Like I said, we tried to integrate this data with MongoDB. And what we did was talking about modeling in MongoDB. We said MongoDB was a document-oriented database that is supposed to hold very large data sets. So the beauty of MongoDB is when you operate a MongoDB cluster that uses master-slave replication. We talked about the CAP theorem also, and we said based on the CAP theorem, the MongoDB supports consistency and partition network partition tolerance. That means, and also it supports that with flexibility. That means you can decide to say, I want to be strongly consistent, or I want to be weakly consistent. MongoDB has that ability to do that. And remember, with the kind of consistency, you give up, you enjoy some little bit of availability. So those are we talked about the properties of MongoDB. It's a document-oriented database. It doesn't use SQL, so everything is represented as JSON, and even your query language is JSON. So we're going to see that shortly. So we said to do that, we had to integrate this data. For instance, you want to compare these, where is it? Entity relation diagram and say, how do we build a data set? How do we build a data set for MongoDB that is object oriented with embeddable objects, so you can embed objects in an object? And how do we model our test results based from, or rather from, this entity relationship diagram? And we discussed that a lot. You want to check that out. So when we finished, we embedded all these into one object, and we said For test results that passed, it will be a fairly simple payload, but for test results that fail, it will even be more complex, right? So we had all that discussion and we read the data, we collected our data and we loaded them into HDFS. The script to do all that is here. We downloaded the data and we loaded them, even the lookup data as well, we loaded them to HDFS. And once in HDFS, we decided to write a code that will remodel these data. Also, if you go to this document, you would see that they created a MySQL table script for that, so you can actually load this data into MySQL. But remember, I told you the size of the data, and you can imagine. And I'm saying I think we actually had a takeaway assignment, even though we don't do takeaway assignments in Hackaday sessions. I made mention of something here. Said, okay, load this data in MySQL, right? Now import 1 year's worth of data and run your query, import 2 years and 3 years, so that we can compare the performance of MySQL and the performance of MongoDB over a single node. Start with a single node and load, say, 2005. If it's working, try load 2006 and start writing this kind of queries that we're talking about. I mean, it's really going to be interesting if you do that. Right, but this is for your practice to understand the benefits of NoSQL database or web scale data stores, right? Cool. So for instance, the 2017 should be over 11 million records. I have downloaded it, I have not tried it. 2015 was way into 8 million records for test results and 11 for items. So as you keep going, you hit 20 something million records, and you want to compare the ability of this database to perform sample analytical queries. So all we are doing is trying to model the data to be able to answer these kind of queries, right? So these are the kinds of queries we want to answer. And definitely, if you load this data into Hive, with your knowledge of Hive, you can write this code. You can literally run this, but remember, Hive comes with its own high latency, and it wasn't built to give you that fast response. And we also try that in MongoDB. So if you go to the code, we actually modeled this in a MongoDB. I just want to show you code. So we had, this is where we modeled it. We talked about creating an external schema, because that is what we did. You can see what the external schema looks like, which we used to describe the data, because we didn't want to infer schemas, right? So we load it and we use the MongoDB Spark connector, and we talked about write settings, which helps us to do flexible consistency level, and we ran it, and this was what our model looked like, our data model. So you have a test result that has a test type, a test outcome, a fail type. If it's a good test, it will have only this, but if it's a test that failed and have multiple items, you're going to have these, right? And these groups can even reach the 5th level. But we stopped at 1. And this is the code that does the modeling and eventual writing. So we did that and we ran it, and it was pretty interesting. So I'm just going to take you to the results. So this is the one big MongoDB collection that now contains our remodeled MOT vehicle testing data, right? I can just click. By the way, I'm using Robot, which is a MongoDB IDE, because since you're working with so much data that is fairly large, using command line only would not be easy, right? But however, right here you can use command line. For example, I can say db the test results dot find, and think I just want to see. So this is the JavaScript that you want to use, right? So you want to see only one record, you can say find one, right? So it is the same thing, but this time you just point and click, but this is how we write it. So you can see this is simple because it has embedded objects. So you want to see how we converted this relational entity diagram right here, and we combine them in here. So if we look for one where the result code is F, that will be, we'll put a where clause in here where the where the outcome dot result code is fail, right? So this is looking like it's taking a lot of time. And we talked about indexes as well. So when you have a lot of record, but I'm looking for one. Oh, sorry, it's failing because I did something wrong. I wrote outcome instead of outcome. So we talked, it's schemaless. It's a schemaless database. So you can see it did not tell me that column doesn't exist. Instead, it is going through the entire document. So this is the problem you have with schemaless databases. I typed in something that was wrong, and it didn't tell me that it was wrong because it's schemaless. It could exist. So it's going through the entire database trying to look for it. And that dialog box you saw was a timeout. So let's hit enter. Now I typed in the correct stuff and I get the response in 0.002 seconds, literally in 2 milliseconds. You want to say how many documents are here? Let's take a look at it. View, I'm just going to change this one here to count. Right, we see 7.4 million records, and you see I just hit a simple search and I get 2 milliseconds response, right? And but that was because I was doing find one, so it returned immediately, saw the first record. So we can see if we remove find one, we can literally, hold on, oh, sorry, should be 10. Good, so I just get 10 records. I'm saying return 10 records that failed. So if you open it, you see a lot more. Now this contains 3 test items. You can look through test item and see record details and parent. This one doesn't have a parent, but you can see the nested structure. So bottom line, we're able to merge the entire ERD systematically in a way that we literally can query any part of the document at any time. And also in that last hacker day, we looked at the query statements that we used to answer the kind of query we saw in that document. So let's see the MongoDB script, and remember it's JSON. So this is equivalent to this. Right now, this is the word of MongoDB. We talked about the aggregation framework, and this is literally equivalent to this. And that is, we're trying to find the initial and completed tests volumes by class 2009, 2000. Now we're doing 2005, so it's going to be 2005. Hold on, we're looking at between these two dates, 2000, this April and April, where the test type code is empty, right? So that is what this query does, just to show you that. Good, and you execute this, it runs, performing a level of aggregation. It does match, it does project, it does a group by, and this is the analytics here. And it's taking time. We go and we see more complex queries, and even we cannot do this. We figured we cannot do this, but because we were coding live in the class, weeks later I figured I could do it, but we did it wrongly. Now the result is we wanted basic expansions for refuse. I've forgotten this word right here. RF hierarchies to the 5th level. So it's not that we could not do it is the right word, but it's possible. And I will show you in this hacker day where I remodeled the data. So we have a problem with this script. I don't know why. No problem with the script. This should return. this should return. So that is something that I will point out, the mistake we made in the modeling, and the mistake actually was in the way we conceived the model. So after the hackaday, I was just looking through the code and I felt, hey, if we remodeled it somehow, then it will be possible. So I think it will make sense for me to just do, I will show you the correction so that we can come back here and I will fix it later and upload that code. Good. So yeah, we're having issues with our queries running. But I'm not going to look to debug this right here. If you go in that hackaday, everything ran, and this is what the query looks like. Not very friendly, but once you get used to the aggregation frameworks, you know how to use the aggregation operator or the pipeline operators, as we call them, a match, project, unwind, lookup. We tried some lookup and add to set. If you actually build them very progressively, because that's how we did in the class. It is cumbersome, but once you get a hand of it, you can use it to construct your own queries. All these queries, like I said, we constructed in the class. Cool. So this is what it looks like, and we got exactly the same kind of result we wanted. You can try it out on your own. So the reason this is failing is the current version of it's taking more than 50 seconds, and the timeout set on this MongoDB server is 15 seconds, so that failure shoots up if you can get it. But I like the 15 seconds failure because I use it to train my queries. Once something is getting beyond 50 seconds, I know this query is not performing like it should, and I visit the query, right? So it's both a blessing and a curse. But in this case, I will take it as a blessing. We need to work on the query, or we need to add indexes. I remember in that class we added indexes, and probably I took out the indexes, and that's why we added indexes, and indexes will help you speed up the query. But right now it came along and it came in aggregate time of 27.3 seconds, and this is the result we get. Yeah, with this tool, you can view it as a table, and you can view it as it originally should be, a JSON or a tree or a table. So that's one of the beauty of this table. So that is it. And you want to take this query and probably try it out in MySQL and compare the way they work. So that was all the stuff. We take a data set and we remodel it to some unpopular or unfamiliar NoSQL database technology, and learn how to get a hand of that technology. And I think if you were part of that data hackaday, you should be familiar with it. Remember in that class, we added indexes, but somehow I think I pulled out some of those indexes. So imagine if I added indexes, and which you can add even after creation. You can even speed up that query by a lot because we did that. Okay, so that is what we did in a nutshell. In this hackaday, we are now going to pivot to another class of database, which is Cassandra, right? So we want to put this down and take a little break. And when we come back, we are going to introduce Apache Cassandra and look at the features. Why is it the most popular wide columnar storage database? We'll look at the read path, the write path. Then we will install it. If you have not installed it, I'll tell you how to install it, how to make it talk with your sandbox, right? Because we're not installing it inside the sandbox. I installed it on the host. You can imagine how this works. So I think it will make sense for me to do that right away. So how did it work? Is that when you create the sandbox, you go to settings and you go to network, right? You can see this is NAT, so I literally can connect. Now I have a router in my home, so the router that helps me connect to the internet and wire my home. So that router gives me an IP, right? That router gives me an IP. So that router gives me an IP, and so with this IP, I am able to connect to the database from another source. However, for me to be able to do that, I have to configure, for example, MongoDB to be able to talk to be able to accept external connections, because by default it only takes localhost localhost. So I need to show you that before we go on a short break. And this is, yeah, and you have Mongo CFD right here. And I say bind IP 0.0.0. So if you don't do this, you may hit the roadblock of, hey, I'm trying to reproduce what you're doing, but it's not working, right? You can reproduce it because you see I'm binding, I accepted binding from all ports. Now in production, you don't want to do this. This is only for educational purpose so that you'll be able to connect between your VM. You should be able to connect between your VM and your host, right? And you don't need to install anything. There are a lot of installations that have gone into the VM. You may have port conflict, so you better stay outside of it and connect from inside, which is probably what you do in production. But this is only for educational purpose to bind 0.0.0.0. Okay, so that is it. Let's go on a short break, and when we return, introduction, Cassandra.